I swear, I think this is one.
Okay, this is more of his baby face, but you get
Alright, today we are going to take a look at the other three trig functions. Okay, this is something that you have not seen before. Okay? In geometry, we talked about sine, cosine, and tangent. Okay, so what we've done so far was mostly review. Okay, the rationalizing denominator part might have been a little bit new. Okay, but this today is going to be new stuff. Okay, the other three trig functions that we're going to take a look at are cosecant, secant, and cotangent.
Oh my goodness.
Okay, it's not that bad. All right. Now the abbreviations for these: CSC, SEC, and COT. Okay, it's not cosec and cot. Okay, it's still cosecant, secant, and cotangent. Okay, even if you see those abbreviations.
Now, wait. Now, are they like the Coca-Cola thing too?
Okay, I mean,
Or is this like a different kind of thing?
it's not a different kind of thing. Okay, they are very closely related to sine, cosine, and tangent. So we don't even need our own memorizing device for these. Okay, as long as we remember sine, cosine, tangent, then it's very easy to get cosecant, secant, and cotangent. Because these trig functions are just reciprocals of the ratios we already know. Yeah, so what does that mean? What is a reciprocal?
It's the opposite. It's like flipped.
Right. It's a flip. Okay, we flip the fraction. So, for example, what's the reciprocal of 2/3? 3/2.
Oh, oh.
So that's if we're doing slope. If we're doing perpendicular slope, we would take the opposite reciprocal. But just reciprocal means we just flip. So we would just have 3/2 would be the reciprocal of 2/3. Okay. So in our triangle, right, how did we define sine? Sine was the ratio of what side to what side?
Opposite over hypotenuse.
Opposite over hypotenuse. Right. Cosecant is the reciprocal of sine. Right? So exactly. Cosecant is just hypotenuse over opposite. What was cosine?
Opposite over hypotenuse. Or
Adjacent over hypotenuse, right?
I said opposite.
Yeah, that's all right. So then secant is the reciprocal of cosine. So secant is just hypotenuse over adjacent. What's tangent?
Oh, opposite over adjacent.
Opposite over adjacent, right? TOA. So cotangent is the reciprocal of tangent. Adjacent over opposite. Kind of.
They look like
Except
circle
backwards.
hooks. Catfish.
There you go.
Oh yeah.
All right, so let's try a couple of examples where we write out all 6 trig functions. Okay. So, on both of these examples, you can just put it in the tray over there. On both of these examples, we are given all 3 sides. Okay, so we're not going to have to use Pythagorean theorem on either of these.
Yeah. Oh, you have to do that thing. The thing underneath.
So, yeah, if we get a square root in the denominator, we will have to rationalize it. Right? So, let's write out all 6 of our trig functions. So, what would the sine? Oh, yeah, 6 trig functions. So, what's the sine of this angle?
It'd be 6 over 8.
6 over 10.
Oh, I can't read.
I guess first we should label our sides. Right? Opposite, adjacent, hypotenuse. So the sine of this angle would be 6 over 10. Does that reduce?
Oh yeah, it's the 3 5.
3 over 5. Yep.
Guys, I did a fraction in my head.
Proud of you.
I'm proud of it, man.
How about cosine? Cosine would be 8 over 10. Does that reduce? Yes. How about tangent? 6 over 8. Yep. That reduces 3 over 4. Good. So now, the new part, writing our cosecant, secant, and cotangent. Okay, the only thing you really have to remember is that cosecant is the reciprocal of which one, right? Secant is the reciprocal of which one. The easiest way to remember is you have to have a co in every pair. So the other trig function that goes with sine is cosecant. Okay, there has to be a co in each pair. The one that goes with cosine is the one that doesn't have a co, secant. Okay? The one that goes with tangent is cotangent. Okay? We have to have a co in each pair of reciprocals. Okay? So sine is the reciprocal of cosecant. So what would cosecant be? 10 over 6, or we can just go ahead and use our reduced version. Really, that'll save us some work. Just write it as 5 over 3. And how about the secant of
5
theta?
over
5 over 4. And the cotangent of theta?
4 over
4
3.
over 3.
I hate you.
It's not that bad.
Oh.
Like,
I know, working the ground strong. As soon as I see SEC, I thought conservation.
God.
As soon as is it biscuit? Is it steak? It's muffin. What is it?
I used to really like the girls, but they're too sugary for me now.
Well,
I usually go for the bag one.
I'm big for it. They have like some like really strong aftertaste.
It's true, they do.
I always get sausage McMuffin with cheese and a hash brown and stick the hash brown on.
Nice.
So good.
Muffin is
They
best.
sound good. I like the bagels.
I've never had that.
Like a nice bag.
I like McDonald's bagels.
I'm not.
Alright, so let's do the same thing with this triangle, okay? This time our theta is up here. So with respect to theta, we want to label opposite adjacent hypotenuse.
6 is adjacent. No. 6 is adjacent. 4 the square root of 3 is hypotenuse, and 2 square root of 3 is opposite.
Bingo. Good job. So let's list out our sign. Sign would be
Opposite of
opposite over hypotenuse. So 2 times the square root of 3 over 4 times the square root of 3. That's not a real good answer as it is.
If I'm gonna leave.
No, we're not going to leave it like that. What do we need to do?
You just gotta do both.
You can divide the 2 and the 4.
We can divide the 2 and the 4. So
It would be 1 over 2.
2 over 4 would reduce to 1 over 2. Then I still have these square roots of 3. What do I do with those?
Times.
It's square.
You times the square root of 3.
So from everything we've looked at so far, we would multiply numerator and denominator by square root of 3, right? But, hold on. Since these are the same thing, right? Square root of 3 and square root of 3.
Just one.
We can just cancel. It's just 1.
Oh.
Oh.
Okay? So it would not be wrong if we went through that process of multiplying by the square root of 3 over square root of 3. We would just have to reduce again later down the line. Okay? It would just be a little more work. We would still get to this answer of 1 over 2. Eventually, it would just take a little bit more work. So, about cosine.
They said hypotenuse is 6 over 4 to the root of 3. And then do both sides of the square root of 3. Put yourself over.
This time we do have to multiply top and bottom by square root of 3, so we can't cancel that out. Okay? So we'll get 6 times the square root of 3 over. So square root of 3 times the square root of 3 is just going to be 3, right? We can kind of skip that step where we write it as the square root of 9 and then write it as 3.
I have 9
6 times the square root of 3 over 12. Does that reduce at all? How? Yeah, so 6 over 12 just reduces to 1/2, right? So I can just write that as the square root of 3 over 2.
Wait, so why'd you put the 3 in the parentheses?
To show that we're multiplying. I mean, I could just write it as 4 times 3 like that. Right?
I know, but like, why are you multiplying it?
Well, because that's what we're doing here, right? 4 times the square root of 3 times the square root of 3. So, this would really end up being 4 times the square root of 9, which we know then is 4 times 3.
And 2 to the square root of 3 over 6.
2 times the square root of 3 over 6. Can I do anything with that one?
Not 2 and 6. 1 and like 1/3.
Exactly, yeah, that will reduce to 1 times the square root of 3 over 3. So now, let's write our other 3 trig functions. So which one goes with sine? Which is the reciprocal of sine? That's good. Cosecant. So what's my cosecant?
I thought it's over. So 4 to the square root of 3 over 2 to the square root of 3.
So, yes, but we can just use our simplified version of sine, right?
It's 2 over
So I can just make it 2 over 1, or just 2. How about just secant of theta?
Garbage.
2 over the square root of 3.
So we could write it as the reciprocal of this.
And then which time by square root of 3?
Right. And we can't have square roots in the denominator, so we can multiply numerator and denominator by the square root of 3. Get 2 times the square root of 3 over 3.
Why can't you have square root of 3?
It's a good question.
You know the answer to that?
Actually,
Well, I think it was just a consistency thing so that you could look at 2 numbers and know whether or not they were the same number, you know, to get a set simplified version.
so it's just an arbitrary rule somebody made up to make sure everything was consistent.
Oh, I don't care.
All right, so we took our simplified version of cosine, took the reciprocal, and we had to rationalize. Now, another way that we could have done this, okay, so that we didn't have a square root in the denominator, was to actually take our original version of cosine and take the reciprocal. If I would have done that, I would have had 4 times the square root of 3 over 6. Then we just reduce 4 over 6 and get 2 times the square root of 3 over 3. Okay? So either way you want to look at that is fine. Right? You can just always take your simplified version, take the reciprocal, and then rationalize if you want. Or you can look and try to figure out a way where when you take the reciprocal, you won't have a radical in the denominator.
Pull a number from any of those.
Exactly, yeah. I could have taken this one, I could have taken this one, this one, this one. You could take any of those things that are equal to each other. Yep.
We leave to talk about materials because videos like that.
Sure. And our last one, cotangent.
I think it ends up being 1 to the square root of 3.
Yeah, so
It's 3 over the square root of 3.
right, so there's no simplified version here where I could just take the reciprocal and it would be nice, right? So we have to go with our final simplified answer there and then rationalize.
That should be 3 to the square root of 3 over 3.
Right.
And then I got 1 to the square root of 3.
Yeah, exactly. Those 3's will cancel.
But you wouldn't.
And it's just square root of 3.
Good job.
Good job, you. Questions so far?
It's only on yet.
Kind
Not yet.
Not yet.
Alright, we're doing good on time.
Now we're probably like a
Whoa,
solve.
what happened there? That's weird. I don't know. It kind of messed up when I saved it as a PDF. I guess I
You watch all your
have to go back to the. No.
That's the thing you can't actually,
Go back to the Word version.
although it actually really doesn't pick up what I'm saying.
That's the problem. Alright, so we just have the same process here for numbers 3 and 4. So I want you guys to try these ones. Right? Write out all 6 trig functions, rationalizing denominators if we need. Okay, so we'll take, I don't know, 7-8 minutes. Okay, try these ones here.
Okay. That's just the fishing.
I do, but it's been a long time since
It's Lindy like
I've
fishing. No one go fishing.
it always ends up like summer, like, oh, let's go fishing. Oh, we have to go get a license.
I need to get some lures.
I'm about to end up buying you a whole box of tissues.
What I mean, you just go catch bluegill, little panfish.
No,
Are
wait.
you like, oh, I'm gonna catch me a catfish, crappie?
I got a question.
The thing, you go catfishing, all you need is
So where the theta is,
circle hook and
how you want to determine which one's going to be opposite and which one's going to be adjacent?
So the side that is not touching his head, so this one, would be the opposite side.
Oh.
So, I mean, it might help if you draw a little arc, and then you can really easily see if these two sides are touching that angle. The one that's not is the opposite
that
side.
whole back section. Be careful.
Huh?
No. Second. Big boy, Elijah's.
Talking about fishing.
Oh, I don't want to hurt you.
Uh,
Oh, you gonna catch a big catfish out beach road.
You can't catch them barely anyway.
Then that's why I have so many pictures of me catching big catfish. Basically,
was it just 3 that we were doing? Or are we doing 3 and 4?
You can go ahead and do 3 and 4. My secretly a black box.
Yeah.
No, it's not.
Did I scare you? And I'm like, hell yeah, you scared me. I got a foot palm to the face. I was scaring anybody.
Little toe shoes. Why are you kicking the face with some toe shoes out? Oh, I'm so mad. His hands are locked in and toe shoes go.
What? Shoot, I did.
I know I'm not supposed to look, but I'm gonna. I know they're up there.
I thought the sub. I thought you said the sub is just canceled.
They do.
You just say that, bitch.
What? No.
I heard something.
Yes.
So,
I think you're
I heard catfish. I thought that myself.
oh.
Okay.
Okay.
So,
The square root's still in the denominator.
right, yeah. So we would solve a 1 in the numerator then when I cancel out those 7s.
Oh,
This is too
oh,
much.
okay, so. Oh, yeah.
This is way too much.
You just said it was easy.
It is, but then that one got me all.
Just go to
You ever
the
tell you
square
about
root
how
and
to
denominator.
Yeah.
Cancel out the sevens.
Yeah.
He said, well, I was like, yeah, Mikey thinks that you're so funny and stuff. And he's like, well, why doesn't Mikey ever pick me up or anything? I'm like, I don't know. He has me on my old Facebook. Just kind of new Facebook. He always gets kicks off of, he gets banned from Facebook for a few days.
Why?
Well, he's a big old lady.
Oh, I see him going after people all the time. It's the funniest thing.
Yeah, did you guys hear about that shooting at Monument Park last night?
No.
Shooting in Monument
Yeah,
Park.
people died.
Oh no.
The girl that did it, there was 3 people. One of the girls that did it, Tyler went to school with.
Uh-oh.
Batch, did you hear what happened last night at Monument Park? There was a shooting. Yeah, it was a mass shooting. People died.
Why do you say people died?
You're like, I thought I heard gunshots last night.
You say, do you live over by the Fach? I didn't hear anything. Your house
Yeah,
is too far down.
it was on
More by the
Facebook.
fairgrounds. That's hard.
What time?
I don't know. Tyler's like, yeah, it happened Thursday. And I'm like, today's Thursday, Tyler. And he goes, oh, screw it. It is Thursday. Well, you should. I used to rush. I got much.
Megan,
Yes.
you got some cough drops.
I'm gonna use
What?
Not doing that. I'm not mean. I'm just.
If you do want, I do that.
I. These are strong ones too.
What is it? Is it the ice one?
They're burning
That's
it
one
through.
there.
I like the strawberry.
I hate the strawberry cone. It's just it's way too sweet.
I love sweet.
I think I left my gum in the car.
What?
No.
What?
I had too much stuff in my coat pocket. Oh no. I really wanted that gum.
Well, that's more possible. Still not. Not me if you're flying with that person. I smell hot pockets. We're talking about you smell beef. You have a problem. Well, you need to stop eating them.
Oh, it's not today. See, I just
Like, it smells like your breath. No offense. I'm not trying to be mean. I'm just trying to be truthful.
honestly, I woke
Your
up
breath
today, I
smells
thought
like
it was
sulfur
Sunday.
bits in hell.
I wish it was Saturday.
Sulfur pits.
I thought yesterday was Friday
Salt.
all day.
Sulfur pits.
I think
That was
everybody.
the worst. I did that last
Sulfur.
week. And I was in the car thinking, I was like, I
You
smell
can say
like
sulfur.
I've been wrong. He goes, why are you
There you
doing
go.
on Friday?
Hits.
I was like, no, today's Friday. No,
There you
today's
go.
Thursday.
That's what we do for the next
Annika posted on Twitter, she was like, I feel like everyone's having an off day, and that's what it did seem like.
Triangle.
Like this week went by really quick.
Opposite can. Kai.
Why?
What about the other?
You always hate your job.
I did,
so
but I
that's
hate it
the-
even more now.
I gotta
Why?
make my own triangle?
Because I learned that I might be getting a new job soon.
Why they give me one?
But so far
So you have
I've
to
heard that
figure out
my
what to do.
manager has
So you know
harassed
two
my
sides
friends
of that
slash
triangle.
coworkers
Oh, do I have to?
and
Is
basically
this something a
running
lot
a
of
drug
work?
cartel in this.
Like,
That's why
I'd call-
cause I get drawn.
I'd call, like,
wherever
wherever the thing
Oh no, they
is.
called HR and they don't believe any of us.
Oh.
And
Then you
several
have to
people
write
have
it out.
wrote 2 to 3 pages
Don't do
about how
that.
this is wrong. I will be hitting soon.
Entrance exam.
Yeah.
Wait, what?
Alex.
Like,
Two,
you
like
pass-
5 of my coworkers are
there's
already
three or
put into
four
2.
different
No,
tests.
did you say someone sews them?
People are writing letters. 2 3-page letters.
All right, take a look up here at my answers. How did we do? Okay, so on all of these actually, I chose. So once I figured out my sign, okay, I actually chose this version right here to make my version of cosecant. Okay, if I just take the reciprocal of this, I get square root of 2 over 1. That's as simple as we can get. Right? Same thing here. The reciprocal, I took this version of my cosine. To get the square root of 2 over 1. Plus, that reciprocal of 1 is just 1. Over here, okay, I actually took my first version of sine. Okay, the reciprocal of 2 over 5 square root of 5 is just 5 square root of 5 over 2. And we can't simplify that any further. Same thing here. I took the reciprocal of this version. We got 5 square root of 5 over 11. Then we can't simplify 2 11ths. Its reciprocal is just 11 halves. Now, if we did not recognize that these were the easiest versions to take the reciprocals of, and we just took our final version, took its reciprocal, and then simplified, we would eventually get to this. Okay, it's okay if you don't recognize right off the bat that this is the simplest version I should take the reciprocal of. It'll save you some work if you recognize that, but it's okay if you don't. Right? If we took this reciprocal and then rationalized and simplified, we would eventually get to this answer. Right. Any questions so far? Alright, then let's take a look at the last 2 down here. Okay, these ones look a little bit different because we don't have a triangle. All we have is one trig function. So from that information, how am I supposed to get my other 5 trig functions?
A squared, B squared, C squared, and just take those numbers as A and B.
Exactly, right? This information gives us 2 sides in a triangle. Right? So I'm going to go ahead and sketch out my right triangle. Put my theta there. So what I know is my opposite side is 1. My adjacent side is 7. We can now solve for this third side using Pythagorean theorem. So I'll make that x. So what would my setup be here for Pythagorean theorem?
1 squared plus 7 squared.
These are my a and b, and then the hypotenuse is c. So 1 squared is 1, 7 squared is 49. So we end up with the square root of 50 equals x.
Wait, you're going too fast.
Okay. So now, with these 3 pieces of information, I can write all 6 of my trig functions now. So I'll start up here actually. Sine of theta, what would my sine of theta be? I guess I always want to jump the gun. We should label the sides first.
It's
So sine then is what?
opposite over hypotenuse.
Opposite over hypotenuse. So 1 over the square root of 50. So what do I have to do?
Times 50. The square root of 50.
Multiply both numerator and denominator by the square root of 50. get square root of 50 over 50. How about cosine?
Opposite. Wait.
Adjacent over hypotenuse, so 7 over the square root of 50. And again, we'll have to rationalize. So multiply top and bottom by the square root of 50. So we get 7 square root of 50 over 50.
This is too
How about tangent?
Adjacent. Opposite of adjacent.
Opposite over adjacent. So 1 over 7. And I'm done, right? I don't have to do anything else with that. So then let's write our new trig function. So cosecant, we know, is the reciprocal of sine. So which, should I choose this version or this version? Take the reciprocal of. Which one is going to lead to the least amount of work for cosecant? Mike?
Good. Right, fresh boy.
Fresh boy?
Oh, wait, you're on sin? Okay. Yeah, fresh boy. Put 50, screw with 50 on top. Oh, one.
Right.
The fresh boy.
Right. So I'm just taking the reciprocal of this version of sine. And I don't have to rationalize. Right? My square root is in the numerator. Square root of 50 over 1 is just square root of 50. Right? How about secant? So secant is the reciprocal of which one? Cosine. So which version of cosine should I choose?
Fresh boy.
Fresh boy.
Is that the actual?
Yes, that's the actual one.
No, Mike, you just made that.
It's GM. Trademark.
Alright, and our final one, cotangent. That fresh boy.
But that's it's fresh boy.
Yeah, there's only one version of that.
It's
Right?
the fresh boy.
Yeah, why not?
Whatever she does.
Come here. You put your brace back in. Then you whipped them boys out.
Questions on this?
I've been sitting
Are we getting homework
here
tonight?
for like
So, as long as we finish up number 6 here before we get out of here, no homework over the weekend, alright?
Well, let's hurry up.
So I want you guys to try this one. I'll give you a little push to start. Okay, so secant is equal to what over what? Like opposite over adjacent, hypotenuse, what's going on here?
It's equal to cos.
It's the reciprocal of cos.
And it'd be
Cosine.
15 over 17. And adjacent would be 15 and hypotenuse would be 7.
So, as it's written, right, we can just write, this is the hypotenuse over the adjacent side. Right, so, see if you guys set up your triangle using these 2 pieces of information, and then write out your 6 trig functions. Okay? So set up the triangle, use Pythagorean theorem to solve for the missing side, and then write out all 6 trig functions.
Is this one that wants to do the Pythagorean theorem too?
Yes. Yep. This one we will have to use Pythagorean theorem.
Oh my gosh, why would you say that? My own money. Why do you guys have 4?
Oh, this is confusing.
So,
I can save you some time.
you are correct, but I'm still gonna write it down.
It makes more sense if you I just write sin and then I write kiska and then cos and sec and then cot. They're all
That's fine.
instead of writing them all out.
Yeah, that's fine.
What would you call one of these inside the fresh bowl?
Our initial ratio. I think we're gonna be close.
I almost bought you a fat pack of markers last night from Washington. I was like, what you need markers for? For my teacher. No!
You don't need to buy me markers, Mike. I appreciate it.
All you gotta do is that.
I appreciate the effort.
You're pretty fly for a white guy.
Go away now.
It's a good song. I like that song.
That song is so old.
It is a very old song.
I used to sing that song when I was little. My mom would yell for singing it.
How old?
Oh, this is a lot of work.
These can't be long problems. So did we get our missing side in our triangle would be 8. Then sine is 8 over 17, cosine 15 over 17, tangent 8 over 15. Then cosecant 17 over 8, secant 17 over 15, and cotangent 15 over 8.
Yep.
I got confused.
I
Kind of
finally finished with my paper.
Why is that?
I don't know. I couldn't figure it out.
Where'd you get stuck?
So like I was like trying to like figure out like where to put the theta sign in. Like,
Okay. Yeah, so when you draw your right triangle, it doesn't matter. So I could have put it up here. If I would have put it up there, then this would be opposite, adjacent, and hypotenuse. Then my 15 would go here.
Would you still get the same
You would
answers?
still get the exact same
Are
answer.
you kidding me?
Yep. So it does not matter where you put the
If I would have knew that, I'd just bought it.
data. Well, now you know. Alright. Any other questions?